Okay, Jocelyn, Marcus, are you back, Marcus?
Oh, yeah.
Yeah, okay, all right. So let's continue with the class. Okay, we're starting a new topic here. So before the break was about operations. Okay, going forward, get the result or go back, right? Get the two functions. So now the next part is called composition of functions. So same thing, okay, in a way that we are dealing with more than one functions, okay? So, but then it's called composition, not operation, right? We're not adding, subtracting, multiply, divide. So what does the word composition mean? Okay, can anybody give a just what you think? Okay, even though you don't have to give a precise definition, just think of your mind. What does composition mean? What do you think, Eric? The word composition.
Like a combination of like more than one things.
Okay, very good. Good word. Okay, composition, you can think of it like combination. Okay, you guys can write this down. Combination of function. So it's different idea from adding and subtracting. Okay, that's also kind of like combined, but we are combining differently. Okay, not just add, subtract, multiply, divide. We're combining in a way, okay, we in a different way, so that's why we create another word. It's called composition. And functions here, I would like to give you an analogy. Okay, I use factories, okay, factories. So recently, the Apple company has just announced a new iPhone, right? iPhone 13. Probably some of you already know that, right? So to make an iPhone, right, they need to have little parts being assembled, right? So of course, not everything is being assembled in US, right? So what happened before they produce the iPhone? Does anybody know? What's the process before the iPhone reached to your hands? Lady?
Like before getting.
Yeah, before getting to the States, what's happening? Getting to your home, right? Before they send to your home, how do they make it? Just a general idea, yeah.
They make it, they didn't deliver it.
Yeah, they need to have a DHL to send it to you. How about before that? Before they have the product, how do they make the product? Plan, yeah, very good. Okay, and so they need to have a research team, right? Drawing out the plan, and then after they have the plan, what do they do?
They bring it to the factories and make it.
Okay, and when they bring to the factory, okay, and they need to order the parts, right?
Yeah.
Yeah, very good. Okay, so when they order the parts, not every part is available in one factory. So you need to collect the parts from different parts, right? So first of all, you will have one factory. Okay, so let's say this is group A, right? Factory A is making the plan, right? And then they submit the plan to factory B, right? B will look at the plan and then say, okay, I'm going to order the parts that's needed for the plan, right? So order the parts, right? And then produce, right? In the factory B, they start to putting all the parts together and then produce, right? And then send it to C, factory C. So C could be like the delivery center, right? So send the parts, assemble them together, and then send it to C. So you deliver. Okay, so different area, delivery site, okay, parts assembling sites, planning sites. So each factory has different functions, okay? So these are the three different locations, and in between, you have different factories. So we could have factory F, right? Let's use different color. Okay. So let's look at here. Okay, so try to understand what's happening here. So we have factory F, right? F of X. Okay, so factory F is making the plan and then sending it to parts. Okay, so it's connecting the plan to parts. And then once we get the parts, factory G of X, we call that G of X, right? You take all the parts, put them together into a phone, right? And then send it to the delivery site. And then they are ready to be delivered. Okay, so it takes two different factories to make the whole thing work, right? So composition of function is that we want to combine the two factories together. So create a new factory. So for example, instead of separate into two factories, we just have one and then that can do everything. You send a plan into that function, that factory, and that factory can also put the parts together and also complete the product and then send it to the delivery site. So the resulting function is called the composite function. So that function, that new factory, we call that the H of X. That can do everything. Okay, so that's the idea you can keep in mind right now to understand what's going on. It's different from just adding and subtracting. Okay, it's doing different job. Okay, factory takes factory of like function takes an input, creates an output, right? So for F, takes the plane, right? You need to have the plan, and then using the plan, you create the parts, right? Output the parts, okay? And factory G takes all the parts, put it together, and then turn it into a delivery product, right? A product that you can deliver, okay? But if you have H of X, which is the composite function, you can just submit the plan into H of X, and then it will do everything, and then all in one side, right? All at one side, and then just do the delivery. So of course, H of X will be more efficient, right? So that's the idea, okay? Kind of like a relay race as well. So now let's look at the definition, okay? It should make more sense. Well, in the definition, they put the letter in a different order, okay? So instead of F first, they use G first, okay? So let's reverse the order, it doesn't matter. Okay, so make sure you can copy this notes down, okay? So G of X, right? G of X, which is here, right? The first factory goes from A to B, right? A to B. So turning the plan into parts. And then F of X takes the parts that you have and then produce it, right, into a phone and then send it to the delivery site. So B to C. Okay, now if there's a different factory that goes from H of X, it goes from A to C, then we call that H of X. Okay, so the H of X is called the composite function. Okay, so the symbol for it to, like for us to write it is like this one. Okay, different from add, subtract, divide, multiply, right? What it means is this. Okay, so the way to say it is F of G of X. Okay, so right now the symbol might be very like confusing. Okay, we'll try with examples. Okay, you'll know what it means, right? So let's look at the following example. Okay, but right now, do you understand the analogy here? Okay, of the factories. Okay, can you raise your hand if you understand this example. Don't worry about the symbols yet, okay? You'll get used to it. Okay, so we're trying to find a new factory that can go directly from plan to delivery. Okay, so here the first factory we have is this one, right? The red one, okay? F of X is a different factory. So here we want to do, this is called F of, okay, we'll write this down, okay? F of, the way to read it, okay? G of 8, okay? This is how you read the symbol, okay? All right, so our first input, okay, our plan, right? Remember the beginning, you need to have a plan. How to make an iPhone, right? Your blueprint, right? So the 8 is your input, your first input. Okay, so we'll put that 8 here. 8, that's your plan. Okay, so first the 8 is going to the first factory, which is the G of X. So it needs to turn that into parts, right? You need to order all the parts, right? So you put the 8 will go into the G, okay? I should use red for this one, okay? So put 8 into our function, right? G of 8. So G of 8 is what? Nick, what do you get for G of 8?
16.
16, very good, okay? So you put the 8 into the X of the G function, right? So it'll give you 16. Okay, this thing is from G of 8. And then those are the parts, right? And then you take those parts and then send it to your second factory. Try to make the phone, right? And send it to the delivery site. So you put 16 into the second function there on the top, right? So what would you get out, right? What's your final product there? Daniel?
4.
4, very good, okay? So you get a 4 out. So that's your phone that's ready to send to the delivery, right? At the delivery site. So this one is your, let's write it here, okay. So G of 8 is 2 times 8, okay? And then the 4 comes from F of 4, which is square, F of 16, sorry.
Jason,
Yeah.
for the bottom part, is it fine if I just wrote F of G of 8? Because it's the same thing, right?
The final part?
Yeah.
Yeah, it's the same. Yeah, you can write F of 16 or F of G of 8. Yeah, it's the same. Okay, it'll give you the also root of 16, which is 4. Okay, so this just another way to explain what's going on. Okay, but when you are doing the work, okay, you don't need to draw the chart like this. Okay, but drawing the chart help you understand what's happening. So last part is delivery. So you deliver the 4, okay? 4 is your final product. Okay, now to show the work, okay? Back to the top here. So as you can see that the 8, first you need to put it in G, right? So you put 8 into the G of X, you get 16. So to show work, you write F of 16. Okay, and then now you know 16, you will go into the F, then you get the final result of 4. Okay, so this part, these 2 steps, the yellow highlighted, that's your work. Okay, you show me how the G of 8 disappear, become 16, and the F of 16 become 4. Okay, so I would like you to try question B first, okay? Just the top part. Also make the chart, okay? Make fill in the numbers in the circles. And then show the 2 steps. Okay, show the 2 steps. So this time you have f of 16. Okay, you are using only one factory. Okay, so let you guys try it. Okay, at the end you will again get a single number. So please raise your hand if you finish the work and also the chart. Okay, the circle chart. We should call it a mapping. Okay, mapping diagram. Okay, mapping. Okay, you always start from inside. Okay, start with the 16 and then slowly go outwards. So of course you could have more than 2 factories, right? You could have something that takes longer to produce, right? More process. Okay, does anyone have question about question A so far? Okay, please raise your hand if you finished B. Okay, Marcus, can you tell us how to start the first step?
You put 16 in the first box. Alright, single.
Yeah, put 16 into the F. What do you get?
You get square root 16.
Which is
4.
4. Okay, so the first part, the inside will become a 4. Okay, this part, the underline will become a 4. Okay, very good. And then Jocelyn, what do you do with the 4 now? Jocelyn,
Yeah.
yeah, what do you do with the 4 now? Do you know how we got the 4?
Yeah.
Okay, so what do we do to continue?
Wait, I'm kind of confused.
Which part? How we get the 4?
No, like how to like the next step.
The next step. Okay, so this 4 is inside the F, right? It's called F of 4 now, right?
Yeah.
Okay, so that means your 4 is your input. You're going to put a 4 into the F of X. Where's your F of X? What's the F of X in this question?
The second box.
Yeah, what's the function? F of X equals to what? Look at the question right on the top, the green one. What's F of X equal?
Square root of X.
Yeah, okay. So F of X equals to square root of X. That means anything that you see inside the F, you put it into the square root. Okay, you see the shaded box there, right? Anything that's there, you put it into the square root, okay?
Okay.
So now you see F of 4. So what do you do with the 4?
Put it in the square root.
Yeah, what do you get then? Hmm? What do you get?
2.
Yeah, you will get 2, right? So you get square root of 4, which will be 2. Okay, so if we try to draw the 3 circles, okay, Jocelyn, what should go into the first circle?
16.
Yeah, very good. Okay, and then 16 is going into the f function. What will come out?
4.
Yeah, very good. And then the 4 will continue to go into which function?
2.
It will go into the same one, okay? F of x as well, okay? And then what comes out?
2.
2 at the end will be 2, okay? So your final answer is a 2, okay? You go from inside out, okay? So it could be f of f, g of f, f of g, right? Or g of g, right? Different combinations, okay? Anyone has question about this so far? So I'd like you to try the bottom 3 questions first, okay? Exercise 6. So I'm giving you 3 different functions here, right? No, 4, right? We have the f, right? We have the g of x, h of x, k of x. Okay. The last one is a 3-factorial question, right? K of h of g of 2. Okay, so remember you start from inside, right? When you show the step, make sure you show how it progress, okay, one by one. Okay, the last one where we need more steps. Okay, we'll check answer for A and B first, okay? So when you finish A and B, you can raise your hand. Okay, right now we are just checking A and B, okay? If you are not sure, then don't do C yet, okay? Just try your best on A and B first. But if you think you're pretty sure, like understand what's going on, you can go straight to C, okay? But raise your hand when you finish A, B. Okay, okay, Evan, yeah. Okay, Angela, Jenny, Jocelyn, Marcus, do you have any questions so far?
No, I'm just taking my time.
Okay. Okay, give you guys 1 more minute. Remember, you start from inside, okay? Inside out.
Jason, I have a question.
This one.
What if for A it came up with like a decimal?
A decimal. Okay. Let me see what you got so far. Okay, this one, question A, the answer is not decimal. It could be decimal, but for this one, it's not decimal. Okay. Can you tell me what you did in the first step?
I found the input, which is 5,
Yeah.
and then
You put the 5 into which function?
the square root.
Okay. We are in question 6 right now. Question 6, there's no square root at all. Right?
Oh yeah,
Right. This one, F, the 5 is the input. So 5 is inside which function, F or G?
F. I mean the G.
G, right? So you look at here, okay, this part, look at inside, right? The red underline, that's G, that's called G of 5. That means 5 is inside G function, okay? So if you put 5, you should put the 5 into the G, okay? So what will come out? Do you see the G function?
Yeah,
Okay, what's G of X equal?
2.
Okay, it will come out as 2, very good, okay? 5 minus 3, right? So be F of what? It becomes F of Jocelyn?
F of 2.
2, okay? So the G of 5 change into 2. And then you continue from there. You know what to do after that?
Yeah.
Okay. Okay, Jenny, which question are you on now? Are you on B?
Yes, I am.
Okay. How about you, Marcus? What are you doing now?
I'm working on B.
Okay. Then can you tell me your answer for A, Marcus?
I got 132.
132. Okay. How about Jenny? What's your answer for A?
I got 15.
15. Okay. And Jocelyn, have you finished question A? Jocelyn, do you have answer for A?
Not yet.
Yeah, okay. Do you know how to do it?
Yeah.
You put it into where? 2 will go into which function?
The F function.
Yeah, okay, very good. Okay, once you get the number out, let me know, okay? Okay, let's get some answer for question B then. Nick, what's your answer for B?
I got -5.
-5, okay. Susan, what's your answer?
I got negative 11 over 4.
11 over 4, negative 11 over 4, okay. And Callum, what's your answer?
Negative 2 and 3/4.
Okay, so at least they're all negative, very good. Oh, 2 and 3/4, that's the same as 11 over 4, right? Okay, so we have a match there. Okay, Jocelyn, have you got it yet? Question A?
Yeah,
Okay, what's your answer?
15.
Okay, you also have 15. Okay, so Marcus? Marcus? Are you
Yeah.
there? Yeah, okay, so did you get f of 2 for the first step?
Oh no, I messed it up.
Okay, do you know how we got the 2?
No.
Okay, what's the input at the first?
5.
Hmm?
5.
5, right? So 5, you should put it into which function?
F. G. Sorry.
G, it's right beside G, so you put it into G first. You go from inside out, okay? So G of X is this one, the yellow highlighted. Do you see it?
Yeah.
Okay, so whatever that's inside the G, right? You see I shaded, right? You will put it into the shaded part. Okay,
Good.
so 5, you'll put it in there. How do we get the 2 then?
5 minus 3.
Very good. Okay, so the G of 5 turns into 2. Now the 2 will continue to put into which function?
F.
F. Okay, so you look at the F function there, right? You see I shaded again.
Yeah.
Yeah. Okay, so how do we get the answer then?
You just plug in 2 into the X.
So can you tell me what to write?
2 bracket 2 squared
Yeah.
plus 3 bracket 2 plus
Very good.
1.
Yeah. Okay, go on.
That'd be 4 8 plus 6 plus 1.
Yeah, and then
15.
15. Very good. Okay, so just remember which one, because if you put 5 into the F first and then put it into G later, it will give you a different result. Okay. All right, let's look at B. B, we have also 2 different answers. Let's get one more. Okay. Lily, what's your answer for B?
I also get negative 11 over 4.
Okay, so it looks like negative 11 over 4. Okay, should be right. So let's try it out. Okay, so Chris, the K of negative 2, what do you get?
I plugged -2. Wait, what answer did I get for that?
Yeah, for K of negative 2.
1 over 4.
1 over 4. Okay, 1 over 4. Okay, does anyone have questions about how we get 1 over 4? Negative 2, you put into K, right? So in fact, you should get negative 1 over negative 4, but you simplify it, you'll get 1 over 4. It's easier, okay? And then 1 over 4, continue to put into G. So it'll be 1 over 4 subtract 3. So you need to know how to do subtraction with fractions, okay? How do we subtract fractions, Evan?
With the same denominator,
Which will be?
4.
Yeah, so the top numerator will be 1, take away.
Oh, is it still me?
Yeah,
12.
12, very good. Okay, so answer, okay, is negative 11 over 4. Of course, you can also use negative 2 and 3 over 4. That's the same, okay? So it looks like most of you got it now. Okay, so you guys can continue work on C. C is a 3 factory question, okay? But doesn't matter how many factory they give you, Okay, just go from inside out. Okay, raise your hand when you finish C. Okay, Eric, what's your final answer for C?
I have 2/3.
Okay. And Sophie, what's your answer? 2/3?
Yeah, I also have 2/3.
Same thing, okay. Philip?
Also 2/3.
Okay, so it looks like you guys agree on 2/3. Anyone got different? I didn't say it's right, okay. Does anyone got different? Okay, Marcus, can you tell us how to start? The first step.
You plug the 2 into G.
And what comes out?
You get -1.
Yeah, very good. Okay, so K of H of -1. Okay, so G of 2 change into -1. Okay, and Jocelyn, what do we do after we get the -1? Do you know how we got the -1?
Yeah.
Yeah, okay, what do we do now with the -1? Where do we put it in?
Plug it.
Which function? F, G, H, K, which one do we plug the -1 in?
The K function.
So you look at the question here now, right? What's beside the -1? What letter is beside the -1? Look at the work on the screen.
Oh, the H function.
Yeah, so you look at the closest one, okay? That's the next. So -1, you should put it into the H. So what happens when you put -1 into H? Do you see the H function?
Yeah.
Okay, what's H of X? What does it say? What's H of X equal?
Equal to 3.
Yeah, equal to 3, okay? So do you see any X?
Again?
Okay, let me erase that, okay? The h of x is equal to 3, so whatever that goes in, right? Goes into here, it will just equal to 3. There's no x to sub in. Okay, it just stays as 3. It doesn't matter what you put in, okay? So -1 goes into h, it will equal to what? What comes out?
3.
3, okay? So even if it's h of 5, h of 7, h of 11, right? It will just come out as 3, okay? That's a constant function. Okay, so Jenny, what do we do next now? We got a 3.
We plug 3 into the k function, so it would be 3 plus 1 over 2 times 3.
Okay, which will turn into
4 over 6, which is 2 over
Okay.
3.
Yeah, very good. Okay, so everyone gets it? Okay, does anyone have question about how to produce an iPhone now? Okay, so this is one step by step, right? You go from the plan to the parts, from the parts into the delivery, right? So this is still not composite, right? This is just one by one. We haven't even touched composite function yet, okay? So one by one is like this. So now I want to go back, okay, go back up. How can I go from, let me erase some work, okay? So it doesn't look that messy, okay? We'll look at the first one, question 8, okay? Now you understand it better. We don't need those notes. Okay, so our goal now is to go straight from 8 to 4. That's called a composite function, h of x. Okay, so this is what we want to produce. Okay, we want to figure out what's that new factory look like, new function. So the way to write it, okay, our h of x, you can put it in the notes here, right? This is called a composite function. Okay, because the question wants us to have g of x inside the f of x, right? So it's written as this way. F of g of x. So you can see that there's no value, right? It's just x. So x represents any input. Okay, so it could be 8. It could be 7, right? It could be anything we want. So we just use x. So the way to figure out the new function, okay, we look at g of x, the inside one. Okay, we have a question in the chat. Okay, yeah, you can go, okay. So the inner function is g of x. So I will write it as f of, our g of x is what, Nick? What's our g of x?
2x.
Yeah, okay, our g of x is 2x. Okay, look at the color, right? I'm using the red for the g of x, so I write 2x. So the inside become 2x. Any questions so far? Okay, can you guys raise your hand if you understand so far what's happening? Where the f of 2x come from? Let me know, okay? Because I don't want to go too fast if anyone falls behind.
Wait, Jason, can you say that again?
Okay, so I'll back up, okay? Yeah, I'll back up. Okay, that's right. So we had here, we had f of g of x, right, Evan?
Yeah.
Yeah, okay, so which function is inside?
G of x.
Yes, okay, so the inner function is a g of x. I'm gonna use the red, right? G of x, that's the inside. So g of x from the question, it equals to what?
2x.
Yes, so I'm going to replace the g of x with 2x.
Oh, okay. Thank you.
Yeah, very good, okay. Anyone else have questions? Okay, can you raise your hand if you understand up to now? Okay, so I can go on. Hi, Selena, welcome. Okay, you just finished Chinese?
Yeah.
Yeah, okay, okay. Yeah. So we are on page 6, okay? Callum, Chris, Eric, Nick, do you have questions? How we get f of 2x?
Nope, I just forgot to raise my hand.
Yeah, you
Sorry.
gotta raise your hands right now, okay?
I forgot to raise my hand as well.
Yeah, how about Callum? Callum, do you get it? Oh yeah, I think he told me he's gone to washroom. Okay, I forgot. Okay, so back to, oh, you're back. Okay, so Callum, I'll go over it one more time, okay? So f of g of x. Okay, Callum, can you turn on your mic? Okay.
Oh, yes.
Yeah, okay. So f of g of x here. Which function is inside?
Oh, g of x.
Yeah, so g of x in the question that equals to what?
Oh, could you say that again?
G of x in the question on the top, okay, what does g of x equal?
2x.
Yes, so I'm going to replace the g of x with 2x. Does that make sense?
Yeah.
Okay, so that's g, okay? It's a weird g, a weird way to write a g, okay? But anyway, you know that's g of x. Okay, so now everyone gets that. Now I'm going to continue, all right? So now the input is 2x now. So that 2x is going to go into the f. Okay, so in the question, what's the f of x equal? Lily?
F of x equals
In the question on the top, what's f of x equal?
2.
Right, on the top, f of, see the screen? F of x equals?
Oh, x square root of x.
Yes, okay, square root of x. So what that means is whatever that you see inside the f, it should go into the square root, into the, under the square root, right? It's like a box, okay? You can replace with anything. So if inside the box, you see a happy face, then you'll put a happy face in there, okay? It's a box, okay? Don't get confused with the x. X is just a box, okay? It can be anything. So back here, right? So inside the f, we have 2x. So that 2x is going to put into the square root of x. It'll be square root of, what should go in there, Jenny? What should we put inside?
I'm not sure.
Not sure. Okay, let's go back to here. Okay. Do you see the F of smiley face?
Yes.
Yes. Okay. So let me erase that. Okay. Let me change that. Okay. Don't turn off your mic yet. Okay.
Okay.
Yeah.
Would it just be f and then square root of 2?
Close. Okay. Let me go over this again. Okay. So this box can be anything.
Mm-hmm.
Okay. Whatever you see inside the brackets after the F, right? This part. Whatever you see in there, you put the same thing inside. If you
Okay.
see a 7, you put a 7 into square root. You see a 9, you put a square root of 9, right?
Yep.
The 9 in there. So now over here in the question, what do you see inside the bracket?
Oh, 2x. So you just put 2x.
There you go. Very good. Okay. So this final function, this is your answer. Okay, our composite function is h of x equal to square root of 2x. Now, whose mic is still on? Okay, then. Okay. Okay, so that's our answer here. Okay, so what that means is this new function, it can carry the 8 straight to 4. Okay, so for example, if you try h of, oops, let me erase that. Okay, so on the side, if I do h of 8, right, we start with 8 and you put the 8 into the function 2 times 8, then that will give you the 4. Okay, so it can carry you straight from the plan to the deliver. So that's why I call it composite function. Okay, it's a new function that covers everything, covers the whole process. Okay, can you raise your hand if you understand how to get the final function here, the composite function? So you need to identify what's the input and you put the whole function into a function, okay? Instead of it, so the difference from what we did before the input is always a number, right? This time the input is a function. Okay, Jocelyn and Marcus, do you have a question on how to get the root 2x?
No.
All right, so we'll try another one, okay? So question B. So let you guys try this by yourself first, okay? Please find the composite function, okay? We are at the bottom here. Let me draw a line, okay? This one, this is called composite function. So identify which function is inside and then put that function into the outside function, okay? So please raise your hand once you got the final answer. I'll use a different color, okay? For the inside, I use red. Okay, outside, I use the green. Okay.
Jason,
Eric.
I've finished this one. Can I go get some water?
Sure. Yeah.
Okay, I'll be right back.
Okay. So the key idea is to remember the x in the function is like a box, okay? You can put anything into the box. Like an empty box, right? You can replace it. Okay, Nick, are you done?
Oh, yes. I didn't realize my hand wasn't raised.
Yeah. And Jenny, how are you doing? Jocelyn and Marcus?
Can you zoom out so I can copy the question A?
Okay, yeah,
Thank you.
okay. Let me know when you're done, okay? Okay, so Jenny, you finished writing?
Yep.
Yeah, okay. All right, Marcus, what's the inside function here?
What is for F? Inside?
Yeah, inside is the f of x, right?
Yeah.
So our first step, we'll write it as f of what? What do we put in there?
Wouldn't it be the input, the 4?
There's no number, okay?
Oh wait, no, isn't it just square root x?
Yes, very good. Okay, our input is a function now. Okay, our input is no longer a number. Okay, so now from here, the root x is our new input. Okay, and then we're going to put it into the next function. Okay, so Jenny, what's the next function that we put in?
Isn't it just root of x again?
Yes. Okay, so we put it in there. So your final look should look like what? Still you, Jenny. What's your final answer?
An- another
Another,
square root symbol,
yeah. And then what's in there?
f and then square root x.
Yes. Okay, so this is your final answer look like. All right, so our composite function for this question will be h of x equal to root of root x. Okay, that will be your answer if they want you to find the composite function. And then let's say I want to test it out, right? See if it works. So remember our original input was 16, right? We want to get a 2 out. So the composite function will take us straight from beginning to the end, okay? So try it out, right? H of 16, and I put into the one that we found. So that will give you 4 on the inside, and that will give you 2, right? So we start with 16, you end up with a 2, then you know your function works. Okay, any questions? Okay, so we have a couple questions for you to try, okay? Before I give you the homework, okay? So on the next page, these 4 questions, okay? When we are done these 4, then we're done for today, okay? Okay, before you go on to, okay, let you try, okay? Question A first.
Jason, did I miss anything? I just got back.
Okay, you can check your answer first.
Okay, yeah, I got the same one.
Okay, very good, okay.
Yeah.
Yeah, so we are moving on to page 7, okay, question A. So here I give you 4 functions, f, g, k, right? Oh, 3, only 3. So we are finding the composite function, right? Find the composite function and state any restrictions. So please show step by step. And raise your hand when you finish A, okay? you might need to simplify for this one, right? You have more like combine the fraction. Okay, so at the end, please add them up. Okay, turn into one fraction. Yeah, sure, clear. Okay, don't do B yet, okay? So question A, finish A and then raise your hand. Okay, Daniel, can you tell us your first step? It will be f of what?
2x plus 1 over x minus 1.
Very good. Okay. Yeah, so your k of x is your input. Okay, so now you guys know how to put it in, right? Function into function. I think the harder part is to how to get to the final answer, final expression, right? How to simplify properly. Okay, Susan, what's your next step after here? What do you do?
I plugged what's inside of the f of x into the f of x equation.
Yep. So how do I write it out?
3 times
Mm-hmm.
bracket 2x plus 1 over x minus 1
Yeah.
plus 1 and then bracket x minus 1.
Bracket x minus 1, like that?
Yeah.
Oh, where did you get x minus 1 at the end? Not sure?
Please. That was after I multiplied. Okay, you can get rid of that.
Yeah. Okay, we're just replacing. Yeah. Okay, so f of x, right? Like a box. So it will replace, right? 3 times the box, right? So 3 times the 2x plus 1 over x minus 1. So I guess you started combining, right? So
Yeah.
to simplify the expression here, so don't stop here, okay? This cannot be your final answer, okay? Otherwise it's incomplete. So of course we want to simplify it. What you can do to simplify is to turn the 3 into 3 over 1. Follow the order of operation again, right? You will multiply first. Let's check you guys your final expression, okay? See if we get something the same. CZ, Claire Z, what's your final expression?
I got 7x plus 2 over x minus 1.
7x plus 2 over x minus 1. Okay, thank you. And Angela, how about you? Angela?
I didn't multiply the 3 in yet.
Okay, all right, so I'll let you do that, okay? Multiply the 3 in and then add with the 1, okay? Think about how to add with 1. Okay, so remember for homework, right? Question like these, do not stop there, okay? It's not the answer yet. You go as far as you can to simplify it. Okay, Philip, how about you? What's your final answer?
7x plus 2 over x minus 1.
Also same thing?
Yeah.
Okay, okay. All right, so let's multiply it, okay? So multiply fraction, numerator times numerator, so that gives you 6x plus 3 over x minus 1 plus 1. Now we have a fractions to add together, right? How do you add fractions? Nick?
Make the denominators the same.
Okay, what's the common denominator here?
1.
Huh?
And I was like, you have to make it x minus 1.
Yeah, x minus 1 for both. Okay. So the first numerator will be the same there. The second one, you need to multiply by x minus 1. Okay, so now we combine, simplify it. 6x plus 3 plus x minus 1, the 1 multiply in. And that should give you this one. Okay, so this is your composite function. Now we need to write restriction. Okay, do you remember from first class we talked about restrictions? Okay, for any denominator, what kind of number you cannot have in the denominator, Chris?
0.
Yeah, it can never be 0, right? So that means in this case, x cannot be what? Evan?
Wait, 0? Wait,
What kind of x? It will make the denominator become 0.
1?
1, yeah. So at the end, you have to write down the restriction x cannot be 1, okay? So let's write that down. Can't equal. Okay, so that's our restrictions. Okay, so your answer will include the composite function and also restriction together. Anyone have questions? So this is f of k of x, right? K is the inside, f is outside. Another way to ask the same question, okay? Another way to write it, this is the same as writing as f and an empty circle, k, like that. Put it in one bracket and then of x. They mean the same thing. Okay, just different symbol, different way to write it. So the order, right? F is still at the front, K is still at the back. Okay, the more right at the back is the inside function. Okay, so for example, question B, right? Question B, you have g of f of x. Okay, so think about which one's the inside, which one's the outside. Right, we'll do one more, okay? One more examples. All right, so Eric, which one is the inside function for this one?
F.
Yeah, very good. Okay, so if you like, you can write it as g of f of x first, right? If you are used to this symbol, right, you start with that and then go from there. All right, so please raise your hand when you finish question B. Okay, so Jocelyn, can you tell me what should I put inside the brackets?
You put 3x plus 1.
Yeah,
Mm.
very good. 3x plus 1. Okay, so it'll be g of 3x plus 1. Okay, and let's see. Sophie, what do we do now?
Plug that into the g function, which is
Yeah.
square root of x minus 3. So it's 3x plus 1 minus 3.
Yeah, very good. Plus 1, right? That's the input minus 3. Okay, and Jenny, can we do anything more?
I don't think so.
Is there anything you can simplify in there?
Could you multiply the -3 into the 3x plus 1?
But they are not multiplying, they are subtracting, right? Look at the original function, it's x minus 3, so it's subtract. It's not multiplying. Yeah.
I don't think so then.
Any like terms? 3x plus 1 minus 3, anything you can combine together.
Oh, you can combine 1 and -3.
Yeah, that's right. Okay, so what do you get?
You get 3x minus 2.
Yeah, okay, so your final look should be 3x minus 2. Okay, now don't forget what else is last thing we need to do, Chris? What else do we need to write?
The restriction.
Restriction, very good. Okay, so Angela, for square root, how do we get restrictions? What's the restriction for the thing inside the square root?
I'm not sure.
What kind of number it cannot go inside the square root?
A negative number?
Okay, very good. So that means the inside number must be
Positive?
positive, so greater than 0, right? Can it be 0 inside?
No.
Square root of 0, will you get an answer?
Would it be 0?
Okay, does 0 times 0 equal 0?
Yeah.
Yes, so 0 is okay, right? So remember, for square root, it's okay to have a 0. So for square root, inside greater or equal to 0. Okay, so Evan, what's inside the square root in this function here?
3x minus 2.
Yeah, so 3x minus 2, you must make sure it's greater and equal to 0. And then from there, you isolate x. Okay, so everyone please get the restrictions. Okay, isolate x. Raise your hand once you got that. All right, so Yosher, what's your restrictions?
X is greater or equal to 2/3.
2/3, yeah. Okay, so your final answer will be this whole thing, okay? Remember to include restrictions as well as part of your answer. Okay, so that's all for the class today. Okay, so later I'll post the homework to Google Classroom. And please, Claire, Zen, please stay after class. And Selena, if you have questions, you can stay after as well, okay? Okay, so you guys, I'll see you next week. Okay,
Thank you.
yeah, you're welcome.
Yeah.
Bye, have a good weekend.
Thank you.
Thank you.
Thank you, Jason. Have a good week.
Bye-bye.
Bye.
Okay, if anyone have question, you can stay after. And Claire, you can work on the homework, okay?
I have a question about the homework.
Yeah.
Well, I'm not sure if we're supposed to make the not graph, the chart, or if we're supposed to just find the x.
You just combine the function. There's no graphing.
No, I mean like the chart.
The
We don't
chart.
make
What chart? What do you mean chart? Do you have an example?
like, you know how we in page
Like
page
this
4 on the top,
table here?
like those kind of tables. Do we make
No,
those?
no, no,
Or
that's for graphing. You don't need to do that. Okay, what you need to do is to get the expression.
oh, okay, okay.
Yeah.
Oh, I spent a long time doing that.
Yeah, so that's why you need to join the Google WhatsApp group. You can ask me questions, right? Or,
Okay.
or send me message, okay? So you don't spend a lot of time doing something you don't need to.
Okay.
Yeah.
Okay, thank you.
Okay, yeah, so let me know when you're done, okay?
Okay.
I'll be online. Okay, anyone else have questions?
Yes.
Yeah, Susan?
Can I ask a question about example 7, question A?
Example 7, question 8, yeah, okay.
Yeah. Can we just multiply the 1/1 by x minus 1? Could we cancel out the x minus 1 on the bottom and only have 7x plus 2?
Oh,
Since they would both be the common denominator, could you not cancel it out?
oh, you mean cancel here and here like that?
Yeah, yeah, yeah.
And then your answer will become just 6x plus 3.
No, 7x plus 2.
But if you canceled out, why would it be 7x plus 2?
Because the 1 is still there, right?
Then the 1 will be adding with the 3 then, right?
Oh, okay.
Then
Okay.
that will make sense.
Yeah, I see.
Yeah, or another way you think of it is, okay, let me erase the red part. Okay, so usually when you're confused whether you can do it or not, you try with numbers. Okay, this is what I do, right? So for example, if I have 4 plus 2, okay,
Mhm.
and then I want to do over 2. So the correct answer should be what?
4? No, 6/2.
Yeah, 6 over 2, right? You add them up first and then answer should be 3. This should be the correct one. But if we do the thing that you were doing, cancel it out, what do you get?
4.
Yeah, 4 or even 4 plus 1. If you want to keep the 1, it still doesn't match the correct answer. Make sense?
Yeah.
So if you want to divide, you need to divide everything at the same time, then it will work. Like 4 divided by 2, that's a 2, right? And 2 divided by 2, that's a what?
1.
1, and then add together is
3.
3, then that will match.
Oh, okay. I understand. Thank you.
Okay, you're welcome.
Bye-bye. Have a good one.
Bye. Okay, any other ones?
Jason,
Yes, you're sure.
can you help me with some of the questions on the final test?
Final test?
Yeah.
Oh, okay, sure, yeah. Okay, let me stop the recording first, okay?